This is Scott Strive doing some math. Today in geometry, we'll be analyzing conditional statements. What is a conditional statement? It is a logical statement with two parts, the hypothesis and conclusion. So let's see what an example looks like. If it is cloudy, then it could rain. Let's look at another one. If I have a job, then I earn money. So if I have a job, then I earn money. So the if part is the hypothesis. So if I have a job, that's the hypothesis. And then the then part is the conclusion. I earn money. Converse. Converse is by switching the if and then parts of the original conditional statement. So let's use this. If I have a job, then I earn money. If I were to do the converse, I would just reverse the if and then. So it would say, if I earn money, then I have a job. Now these statements, when you make their converse, they don't have to be necessarily true. Also, the original statements don't have to be true in itself. Like, for example, if I have a job, then I earn money. You could be working, you could be volunteering, working a job, but not earning money. They don't have to be true. Inverse. It's the statement formed by negating both parts of the original conditional statement. So let's say that this is the original, the OG. So the original is, if I have a job, then I earn money. So the converse, you reverse that. The inverse is you take the OG, the original, and say, if I do not have a job, then I do not earn money. And the key thing is that we basically put the word not in both parts. And then the contrapositive is just the converse of the inverse. So all I do is flip it around. So if I do not earn money, then I do not have a job. Okay, so remember, we have if-then form. That's our original statement. Our converse, all we do is take our original and then switch around our if and then parts. Inverse, we take our original and then we put the word not after, we use the word not in both places. And then contrapositive, we just flip the if and then of our inverse. Perpendicular lines. So two lines are perpendicular. Two lines that intersect to form a right angle are perpendicular. So if I have a line here, and that intersects with this line, and if it makes a right angle, then these two lines are perpendicular. And then a biconditional statement, if and only if, is usually used for definitions. I can go to the movies if and only if I finish my homework. So once again, I can go to the movies if and only if I finish my homework. So with biconditional statements, the if and only if is placed in between. And basically what it means is you can reverse the statement and one thing has to happen for the other event to occur. So if I go to the movies, I can go to the movies if I finish my homework, or I finish my homework. I will finish my homework if I can, if and only if I can go to the movies. So you can reverse it, and it's basically for stated things that are, there's no alternative, basically. It's like, if you want to go to the movies, you have to do your homework. All right, rewrite the conditional statement in if-then form. So all vertebrates have backbones. So we can say if an animal is a vertebrate, then it has a backbone. So we just had a statement, all vertebrates have backbones. To write an if-then, we just put if, and then use the first part, vertebrates. So we could have just said if it is vertebrate, then it has a backbone. But sometimes our English class gets in the way and we want to insert, something that makes sense. Okay, here's some more examples. All triangles have 3 sides. Now this one's easier. If it is a triangle, then it has 3 sides. If x equals 2, and x squared equals 4. Hopefully this is not too bad. Write the if-then, the converse, the inverse, the contrapositive. Okay, so write down everything. So first we're going to start off right if-then statement. If a person is an Olympian, then he or she is an athlete. So once again, if a person is an Olympian, then he or she is an athlete. That's true. Converse. So backwards. If a person is an athlete, then he, she is an Olympian. And that would be not necessarily true. There's many athletes that don't go, that are not Olympic medal, they don't go to the Olympics. Inverse. If a person, so we take our original statement, the if then, and then put nots. If a person is not an Olympian, then he or she is not an athlete. And that would be, if a person's not an Olympian, then he or she is not an athlete. So again, this is false. They don't have to be an Olympian to be an athlete. And then the contrapositive is we take our inverse and then just replace our if and then statements. So if a person is not an athlete, then he or she is not an Olympian. And that one's true. To be an Olympian, you need to be an athlete. Okay, name a right angle. So angle AEB. That's this one here, going there, denoted by that right angle there. Name two pairs of vertical angles. So this is review from last chapter. So AEB, and then opposite of the intersection is angle DEC. So we're talking about this angle here and this right angle here as well. All right, write the following statement as a biconditional. Write the converse first. So when you're writing a biconditional statement, you don't need to write the converse first. If two lines lie in the same plane and do not intersect, then they are parallel. So we're going to get rid of the if and then. So two lines are parallel if and only if I see. This is why they want us to write the converse first. So I'm going to write the converse because it'll make it a little bit easier to make our biconditional statement. And I'll tell you why in a second. If two lines are parallel, so the converse, remember, we just reverse the if and then part. So if two lines are parallel, then they lie in the same plane. They lie in the same plane and do not intersect. So I just switched those two. So I'm going to write my biconditional statement if two lines are parallel. Oh, no, wait. Sorry. Get rid of the if and then. Two lines are parallel. If and only if they lie in the same plane and do not intersect. Now, if I was going to write this the other way, so once again, you don't have to write the converse first, but know that you can. You can reverse it and then make it a biconditional statement. Because if I was going to make it the original, if I was going to make a biconditional statement of the original, it might not make as much sense. So if two lines lie in the same plane and do not intersect, if and only if they are parallel. Yeah, it still works. That's what if and only if does, is make both the reverse and the forwards and backwards true. So two lines are parallel if and only if they lie in the same plane and do not intersect. The reason why we went with this one because that's the definition that they have in the book. Yeah, let's do this again. If then, if it is a square, then it's a rectangle. It's true. Converse, if it is a rectangle, then it is a square. That's false. If it is not a square, then it is not a rectangle. And again, that's once again is if it's not a square, then it's not a rectangle. That's not necessarily true. And then contrapositive, you take the reverse of your inverse or the converse of your inverse. If it is not a rectangle, then it is not a square. And that is true. So you'll be writing a lot of sentences or typing a lot of sentences, however you want to do it, in this homework. Checkpoint 3. Use the diagram below to decide whether each statement is true or false. Angle GLK. So let's use some colors here. Let's call this one red. They're saying GLK and JLK are supplementary. So remember, what does supplementary mean? Supplementary means that two angles add up to 180 degrees. And if we take a look, the red plus the green, does that not equal this whole straight line here? Yes, it does. So that is why they add up to the straight angle GLJ. Okay? Now they want to know if GJ is perpendicular to HK. Or they're saying that GJ is perpendicular to HK, and that's false, because need a right angle. So if they put a box here, then you can say that they're perpendicular. But these are obviously not right angles. Alright, and that is 2.2. Have a good, have a good one.